Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Maximizing Sensor Network Lifespan with Optimized DEMBO Approach. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I am here to present you one of the applications that we have designed in the research domain of IoT sensor networks. So under this research topics, we have designed a protocol for the communication of the sensor network within the network. We have proposed one novel optimization algorithm in order to improve the lifetime of the network. So before moving to this video, let's talk about that what we will cover into this video. In this video, initially we will talk about that in which application areas the protocol can be implemented in the real-time scenarios. Then we will discuss about what is the code, how to execute it, what are the software requirements for it to execute. Then we will discuss about what are the current systems working on in the same domain, what are the problems identified in them, and how proposed work is assisting the research area to get improved outcomes. Finally, an overview to the experimental outcomes and the findings will be discussed. So let's initially talk about the application areas. So the sensor network applications are not restricted to only one or two domains. In every of the sector, either it will be the healthcare industry, industrial applications, market, agriculture, home, everywhere the sensor networks are gaining so much interest. Whenever the IoT is here, this boosts the requirements of the sensor networks in the current market. So, but how it works basically, all these domains are to cover the areas like in which the like wearable devices, security, remote monitoring, sensors, those are able to sense different parameters. They are just sensing the data and sending it to the network, and then from the remote location through the IoT, we were able to visualize them and take the appropriate step if it is required, especially in the domain of the healthcare, in the agriculture, smart home. This is very much popular these days. Now you can see one of the example is like wearable devices, where there are number of the medical sensors in the device. Those are continuously monitoring your health parameters, and you are able to see it from the remote location as well as on the device. So that is one of the example of the sensor network. But the issue with these systems is like these sensors are working on the batteries, like the wearable device, let's say the fitness watch you are wearing, it is having the battery in it and it need to be recharged again and again. So as this device is with you, then you are able to recharge it, but at the remote location it is not easy to change the battery or charge the battery on the daily basis or at the frequent intervals. So in order to handle that issue, these energy efficient protocols are there, where the protocols are designed to save the energy of the sensor so that it can long last for the longer period. So inspired from this, the proposed methodology has been designed in the software named MATLAB. So now let's see how the code is to be executed. We do have this folder with us in which the whole code is placed. You can see every file of this code is written in the MATLAB, so you must have a MATLAB software with you. So the MATLAB version that I am using is 2019, so you must have 2015 or above, but make sure the MATLAB version should be the full version, not the trial version, because there are restrictions with the library to execute the codes. So in order to run the code, you just need to copy this path. You can just copy and then go to the MATLAB. Here just select the path, Control V, paste, and press enter. When you will press enter, you can see we do have all the files, those were there in the folder. Now the files that you need to execute are LEACH code, proposed MBO code, proposed GSA code, and proposed DEMBO code. So the base of this research we took as a LEACH protocol, which is a energy efficient protocol introduced in the domain of sensor network. So LEACH is a protocol. It is low energy adaptive clustering hierarchy. So through which the clustering based methodologies were given in the sensor networks to transfer the data from one location to another. So inspired from this, every sensor network protocols are further improved, and currently in the IoT, the WSN is achieving a good hold. So we have took this as an base. So later on we have implemented to the rest of the codes. So in order to run the code, you just need to select the file whatever you want to run. All these files are where fx is written. These are the function files, so these cannot be executed directly. The main files are 1, 2, 3 and 4. Here you can see there is a icon variation. So all these folders are called in these main functions. So in order to run the code, you just need to select the file and click on the run button. When you will click on the run button, it will start executing and will show the results after the execution. Now let's talk about that what was the issue with the current systems. And here you can see these are like processing during the simulation. These are the nodes deployed. This is the sync here and the cross one, right? The number of rounds are there for the communication, and the graphs will be visualized in the different figure windows. So here you can see these are the graphs that we got from the LEACH one. So what we were saying, that what exactly the current systems were, what are the issues with them, and what we have proposed. So in the current systems, this is just the base, the LEACH one, but even in the other state of art methods, the clustering, the cluster head selection, these are playing an important role in improving the lifetime of the sensor network. So after reviewing the literature, we came to know that there are certain protocols, those are working on the optimization algorithms, but the parameters generally they are considering is only distance, right? So in our proposed method, we have done the modifications in terms of like applying the latest optimization algorithm. One is GSA, Gravitational Search algorithm. Second one is MBO, that is Monarch Butterfly optimization. It was introduced in 2019. So these two latest optimization algorithm has been implemented along with the factors that we just used in these two scenarios are. Let's see what we have implemented. Here you can see if I'm opening the normal MBO, the fitness function that it does have is cost function file. So this is the cost function. Here you can see the parameters that we are using in the cost function are energy, average distance within the cluster, and distance with the sink. So three of the parameter we have used in order to select the cluster head. So for cluster formation, what we have done, let's talk about that. In the proposed scenario, initially we have improved the cluster formation instead of being it on the random basis of the probability of a cluster head. In the previous algorithms, generally researchers were doing selecting the cluster head first, then forming the clusters. Here what we are doing, we are making a tentative cluster head randomly, then on that we form the clusters, and then the nodes within a cluster are set to the voting, and by using the optimization algorithm, the best node as a cluster head, final cluster has been selected. So this is what we are doing in the proposed one. So the second phase is like in which initially in the first phase we have evaluated GSA and MBO, the performance of GSA and MBO along with the parameter of selecting the cluster head improvement. Then after analysis we got that which of the algorithm is performing well. So we got that MBO is performing effectively in comparison to the GSA. Then we have improved the MBO because there were certain issues in the literature with the MBO. So in order to handle those issues, we have proposed one of the novel technique given in this research only, that is the hybrid model of differential evolutionary algorithm and MBO, which is termed as DEMBO algorithm. So this is what we have done into this. So when we are running this, now let's see how to run the code. I already shown with the LEACH one. Let's see with this also. When I'm running the code in the same scenario as of the LEACH, then I am able to see the results. All these results have been after the simulation are being saved to the mat file. As you can see, when the leach was run, then leach.mat was saved. Now if this GSA is working, then GSA results will be saved at the end, so that we can do the comparison in a collaborative way with the system. So it will take some time, I'm just pausing it and running this is the same network that it was in the leach. So I'm just quitting it and going directly to the comparison one. So every of these codes are basically having the difference of the optimization algorithm that we have proposed. Here the GSA is applied with the advancement in the cluster head selection and all. So let's see how we were doing that. Initially the parameters have been defined here, then we are choosing the tentative cluster heads randomly. So random cluster heads being selected. On that behalf, we are making the cluster that rest of the node which is nearer to these tentative cluster heads. So on that behalf, the clusters are created. Then those tentative cluster heads, if they are involved with any other cluster, we are removing those entries. Later on, we are choosing the best cluster heads. Best cluster head within the temporary clusters formed earlier the stage, we are applying the GSA optimization. In the second code, we are applying the MBO. Here you can see the only difference is with the algorithm. Rest of the scenario for the proposed three categories are same. They are giving us the best cluster heads, then the communication among the node to cluster and node to sync has been done. Same for the MBO, and rest the scenario for the proposed is similar. So let's see the comparison one. So we have run the code with a similar configuration as of leach. Then we have saved the results, and these leach results are with us. So we are just going with the result comparison. So it is there in the folder name comparison code. So you just need to run this file, as I just opened it. So you can see the results, those were there. We have just loaded those results and then run the file in order to see the results. So let's see what results we are achieving. So you can see these are the comparisons for the developed systems. So this is the dead nodes of 4 protocols, in which the leach is the traditional one, GSA is ours, MBO is ours. But after this, we were getting that MBO is better. Here you can see the curve of the MBO is better than that of the GSA. That's why we took the decision to improve the MBO only. So when MBO is collaborated with the DE, it is getting better results in comparison to individual MBO and GSA. And obviously it is better than the leach itself, because that is a traditional method. So this is the dead node graph. This is the alive node graph, which is the inversely proportional to the dead nodes. Then this is the energy consumption, remaining energy. So you can see the depletion of the proposed methods energy is staying for the longer period in comparison to the other models. Finally, we have evaluated the lifetime stability in the terms of the parameters like FND, first node dead, half of the node deads, and last of the node dead. So the rounds with the proposed methodology for which it is staying is higher in comparison to the MBO GSA. But in every of the case, you can see why we have improved the MBO, because MBO is achieving better results in comparison to GSA. So further modifications are still possible. So for that information, stay tuned to our channel, and you can contact us directly for the details. Real-time industrial applications or researchers can contact us directly. Thank you. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.